All right, welcome everyone. My name is Sarah Meyer, and I'm a member of the HEAL Data Stewardship Group. I want to thank you all for joining us today for the 18th installment in our Fresh Fair webinar series, Advancing Reproducibility and Data Use in HEAL, Guidance for Sharing Data Associated with a Publication. This webinar will feature a presentation providing best practices for research reproducibility and data reuse, followed by lightning talks, a moderated panel discussion, and a live Q&A session. If at any point you have a question, please feel free to type it into the Q&A box, which you will find at the bottom of your screen, and we will bring it up during the Q&A session. Next slide, please. We are joined today by our presenters, Anthony Juehne, Dr. Limor Peer, and Dr. Frank Rockhold. Anthony Juehne is a program officer for the HEAL data ecosystem as part of the NIH HEAL Initiative. Juehne has over 15 years of experience within the healthcare field of informatics. He has published best practices for conducting and reporting health research to enhance reproducibility, transparency, and accessibility. Dr. Limor Peer is the Associate Director for Research and Strategic Initiatives at the Institution for Social and Policy Studies, ISPS, at Yale University. Dr. Peer manages the ISPS data archive and supports related efforts to enhance the transparency and reproducibility of research at ISPS. In addition, Dr. Peer co-chairs the Reproducibility Interest Group at the Research Data Alliance, RDA, and previously co-chaired the RDA's Cure Fair Working Group, which produced the 10 Things for Curating Reproducible and Fair Research documentation. Dr. Limor co-founded the Curation for Reproducibility Consortium of Social Sciences Data Archives at Yale, Cornell, and the University of North Carolina, promoting practices that facilitate the digital preservation of the evidence-based research necessary for future understanding, evaluation, and reproducibility of scientific claims. Dr. Peer's work has been funded by the Institute of Museum and Library Services. Dr. Frank Rockhold is a professor of biostatistics and bioinformatics at the Duke University Medical Center and the Duke Clinical Research Institute, and professor of biostatistics at the Virginia Commonwealth University. He has a diverse research interest and consulting experience, including clinical trial design, data monitoring committees, benefit risk evaluation, and pharmacovigilance, and has been a leader in the scientific community in promoting data disclosure and transparency in clinical research. His career includes numerous senior management positions in the pharmaceutical industry, most recently as Chief Safety Officer and Senior Vice President for Pharmacovigilance at GlaxoSmithKline. He has numerous grants, including NIH, PCORI, FDA, the Gates Foundation, BMS, IDOS, and American Regent. And with that, I will pass this over to Anthony to begin his presentation.
Thank you so much, Sarah, and thank you so much to all of my fellow presenters and speakers today, and also thank you to all of the excellent steward and platform team members that have supported the development of this work. I'd like to start with framing 3 objectives and takeaways that I'd like you all to gather from today's presentation. 1, why does sharing well-documented data benefit you? Why does it benefit the scientific community? And how can the platform and the HEAL data ecosystem enhance your efforts even more and make life easier for you? Sharing the data and materials necessary to reproduce your research results provides immense benefit to yourself and the research community, and we understand how we play a key stakeholder role in supporting you all. We want to make adoption of best practices as easy as possible for HEAL investigators. You are not alone. HEAL and the ecosystem are here to help you. as a brief overview of what we want to cover today and an overview of the agenda, we'll have an overview of fair data sharing within HEAL, i.e. why to share data, what and when to share, and why reproducibility matters. Dr. Limor and Dr. Frank Rockhold will present some of their excellent work, and then we'll participate in a moderated panel. I greatly look forward to all of your questions and hope to continue engaging with you all further and learning from you all as well. So, why is reproducibility and sharing data associated with a publication important for HEAL? In achieving a community of fair practice requires both technical and social advancements in data sharing. Most investigators plan for sharing data at the end of their grant period, but the new NIH policy includes sharing in a timely manner following a publication and includes the materials such as protocols, code, and etc. that should be shared too to support the replication of results. And we need to find ways to make implementation of these practices easier. This requires a pivot in framing and timing of data sharing, and preparing earlier within your research lifecycle will make it easier to share your data and reproducible results later. We need to shift our thinking from an end of project deposition or last minute burden, and instead let's focus on enhancing the reporting of the many valuable discoveries made throughout the life of your research projects. With the overarching mission and planned architecture in mind, we ask the question, how can we build an ecosystem in HEAL to increase the value of data sharing and fair practices in and across communities of practice? So why does this matter for the ecosystem? We've engineered the platform and ecosystem in a manner to draw the greatest value from the materials associated with your research outputs and to make those materials findable, accessible, interoperable, and reusable by yourself and fellow investigators and other community stakeholders. Briefly overview of how we've engineered and thought through the HEAL data ecosystem. HEAL compliant repositories provide domain and data type specific curation and storage needs. Platform and DUG provide semantic search and faceted search, allowing research and digital assets to be easily found and used. And primarily, it's important the materials and research results we're surfacing contain the necessary materials and documentation to support reuse. Our primary objectives are to meet investigators where they are, and in this aim, we have many resources to help you and are accessible for support. So what are some main challenges facing data sharing in HEAL? HEAL investigators are producing a wide variety of data types across multiple research domains. And how does this relate to the overarching why of sharing data associated with a publication and some of the challenges we're facing here? The diverse scientific domains and data types across HEAL present methodological nuances requiring specialized best practices for reporting and data packaging to ensure reproducibility and reuse. We need to ensure we're meeting all of our investigators where they are. We must ensure we are selecting sustainable repositories for these data that align with communities of practice, as well as provide the necessary curation, exposure of enriched metadata, and the necessary access and security controls. I'll be presenting some of the overall benefits related to sharing the data and analytic materials associated with your publications more broadly, as well as some examples representative of data types and methodologies within the HEAL portfolio. And our guest today will be representing two key areas within HEAL. Dr. Limor will discuss the benefits and nuances surrounding sharing reproducible social science research and survey data. And Dr. Rockhold will discuss the value and importance of reproducible and transparent clinical research. It's our aim that by the end of today, you will see how the best practices in data sharing could benefit your own science and field more broadly and see yourself in this important mission. The field of pain and addiction research could benefit drastically from open collaborative research driven by data sharing, which we aim to support within the HEAL data ecosystem. Sharing the data and code associated with a publication can improve meta-analysis, systematic reviews, and replication of results. These materials are also crucial for adjudicating edge cases and conflicting findings, especially when you have smaller populations and smaller cohorts and very, very rare diseases of interest. Finally, and most broadly, this level of data sharing and reproducibility can support moving individual fields forward and supporting cross-cutting connections. So you may ask, how might these practices scale and what are the benefits of such sharing? I'll discuss an example here that may be of interest and demonstrate the value here. Many of you are aware of the adolescent brain and cognitive development study, so I won't waste too much time on history. What I would like to highlight is the power of sharing data sets with rich documentation. The ABCD data set contains multiple data types, allowing a broad community of researchers to address numerous questions that can inform clinical and policy decisions related to multi-level factors impacting child health and development. And what I'd like to frame is that you don't know how much value can be extracted from your data if you don't share it. Given the size and diversity of the available data collected within the ABCD study, a culture of openness and collaboration has emerged. Machine learning and AI models have been executed to discover neurological and social determinants of psychiatric illnesses and pathways for effective interventions. Investigators share and compare application of emergent analytic methods and support harmonization through mapping to common data models and data ontologies and standards. And entire journals of special editions are devoted to sharing the latest findings, leveraging the ABCD data. This is simply one impressive example of what new valuable discoveries can occur when data is shared between researchers, allowing for more representative cohorts and complex models to be generated and leveraging advancements in data science. And hopefully you can see how much value can be extracted from just one data set. It's understandable that you may have some hesitancy, and there's been a lot of change in this space over the last decade. So let's try and address potentially some misconceptions about data sharing and sharing your data associated with your publications. Risks to getting scooped can be greatly mitigated. In fact, making your data fair will increase attribution and allow for appropriate licensing and citation. Your data can be of high value, and you don't know the extent of value if you don't share, as demonstrated by the previous ABCD use case. Secondary analyses, mega-analysis, meta-analyses, and the application of machine learning and AI techniques. There's a lot of things that can be extracted from your data, and you don't quite know the value if you don't share it. Most importantly, attention to formatting, documenting, and packaging data makes them easier to use, and we aim to provide you guidance and resources to get the most value out of your data. Data sharing is hard, yes, but it doesn't have to be. And the HEAL platform and Stewards are here to support you. Using appropriate workflows from the start reduce the workload later on. Dr. Limor will demonstrate some easy points of entry for beginning to implement these practices into your own workflows, as well as the great benefits to yourself and fellow investigators, and provide some resources for getting you started here. Importantly, and most importantly, the benefits greatly outweigh the risks, especially when we're all facing the epidemic of chronic pain and addiction that have touched so many vulnerable lives and many of our loved ones. Sharing reproducible research supports reliable generalization of interventions and therapeutics, as well as detection of errors, adverse reactions, and other crucial determinants to successful patient outcomes. In essence, fair data sharing and reproducibility supports accelerating the dissemination and implementation of research findings into treatment and policy, but also ensures we're protecting the safety of patients receiving interventions and honoring our first do no harm principles. You'll hear more about this from Dr. Rockhold and why this should be central to all of our missions. So why is it crucial to share data and analysis materials with your publication to make your research reproducible? First, let's begin with a working objective of what we aim to support through such data sharing practices. Reproducibility implies repetition and thus a requirement to also move back, to retrace one's steps, question or change assumptions, and move forward again. If the relevant documentation, data, metadata, or code are lacking in a publication, it is not only difficult to accurately reproduce study results, but also to move backwards through the applied methods to investigate limitations, potentials for expanding or generalizing study criteria and design, and more importantly, potential avenues for new scientific discovery. I'd like to present a brief analogy that may support framing the issue. Think of your publication as the face of a watch. It's easily read and tells the current state of a domain, question, or method, and where things are moving. However, the research data lifecycle and how the science is done in the background is often far more complicated. If one of these pieces break, the entire watch can break. If one of the pieces is not finely tuned, it will not run correctly, i.e., it won't be able to be reproduced. Each member of your team is an active collaborator in making this watch work, and each member provides subject matter expertise to the operation of each mechanism. If you're only sharing the face of your watch, you're not getting the full credit for all of your excellent work, nor is the community getting the most value out of the work you've done. So science is complicated, yes, and thus reproducibility is also complicated, but we can make this easier. How can we operationalize such reporting and data packaging practices within a publication? The figure on the left is complicated, so you need not absorb every detail at the moment. The important point is this publication represents an example of how each piece of the scientific method is documented, all the dependencies within each process are clarified, and both the data and analysis materials for reproducibility of the results are made accessible and available. You have both a clearly, easily ingestible publication, i.e. a face of the watch, but every piece of that mechanism is made available and clearly described, and you can describe how each piece is connected to one another. In addition to an excellent example of how fair data sharing can be implemented when disseminating an imaging study, this publication also represents the value to the investigators themselves. This publication and the pre-publication has been cited 160 plus times, and the GitHub that contains all the analysis materials has been forked 12 times. It demonstrates not only how citation can be of importance, but also how these materials can be readily reused and expanded upon and engaged through scientific collaboration. When thinking through how to share the data and materials associated with your publication in a reproducible way, it's important to consider all the possible details that can impact the capability of someone to reuse your data and materials. For instance, the figures above demonstrate how independently altering software version and operating system all result in significant differences in MRI value measurements and analysis results leveraging this software. Though such information regarding the computational environment may initially seem negligible, these elements make significant differences in the translation of a research question into a final result and are crucial factors within the scientific workflow. We need to consider which differences within the research method and computational environment could potentially make meaningful differences within the output and thus require more transparency in how we report our research and share our data and materials. Finally, in addition to many of the benefits to each particular discipline or field of investigation, sharing the data and analysis materials with your publication to make your research more reproducible presents many benefits to you and your team. Sharing the data and analysis materials with the publication is related to increased citations, increased collaboration, and attribution of work. Open source software development allows for new features for analyses, visualization, results dissemination, and decision support. Sharing the data associated with your publication allows for increased trust in findings through more effective detection of errors and prevention of publication retraction or corrections. It increases the handoff and teaming within your own labs, as well as more efficient training. In essence, if you're doing this, fair best practices become a part of the culture of your labs and teams, and each team member can verify, test, and build upon the work of one another. Sharing the data and analysis materials with your publications provides a solid foundation for future publications and additional research questions, given that increase of trust and increase of rigor in your findings. And it also ensures effective alignment with policy compliance. We have a number of resources we'll talk about today and also in the slides that we'll be sharing. And I urge you all to take a look at them. And as in regards to calls to action, I really encourage you all to review the HEAL Initiative data sharing roadmap and PI checklist that's linked in the slides here. And encourage you all to go register your study on the HEAL data platform, explore and select a repository for your data, and provide your study level metadata. Please keep your eye out for additional resources as we continue to work through these things, as well as stay tuned for additional HEAL webinars. I'll now turn it over to Dr. Limor Peer, who will provide some overview of the work that she does within the Institution for Social and Policy Studies at Yale University, and her excellent work within reproducibility and supporting investigators in sharing their data and materials.
Great. Thank you, Anthony, very, very much. And thank you to the organizers for inviting me and including me in today's webinar. So my name is Limor Peer. I'm at the Institution for Social and Policy Studies. And I have to say that coming from a different background, I'm just so impressed with the HEAL data ecosystem and all the resources. And I can talk a little bit about the differences in the social sciences in terms of how we set everything up and the kind of data that we have and the kind of resources that we have. So you already have a leg up in a lot of ways. And I hope that the community will take advantage of all of that. So just to kind of frame the context of where I'm coming from, I am based at a social science center, and the way our researchers work, we do a lot of empirical data-driven social science. While the data and the methods are fairly standard, so that's a difference from the depiction that was presented before, we have no unified workflow and no unified computing environment and no unified and somewhat unified, I guess, software that people are using. So there's a lot of variation that we need to deal with. So I'm going to talk to you a little bit about that from the perspective of 10 years of managing these sort of data and managing our data archive, which makes the underlying data and code available for published studies to the world at large. I'll also talk a little bit from the perspective of co-chairing the Cure Fair Working Group at the Research Data Alliance. As Anthony mentioned, this is guidelines for best practices for how to manage and steward materials, data, and code so they can be shared and archived, and helping researchers think through what some of the things that have to happen down the line so they can start working reproducibly from the beginning. So next slide, please. So I did, even though we covered some of this, I did want to start with, on the left, with the what is becoming very much the standard definition of reproducibility. This is from a report from 2019 from National Academies of Science, Engineering, and Medicine that states that reproducibility is using the same data, the same methods, the same code, everything to achieve the same results. So we're looking at something that is akin to computational reproducibility. As we are all now using computation in one way or another, that is a way for us to get reproducibility more easily, at least technically. Anthony did a great job talking about the benefits of reproducible research, primarily for the discipline, for science, for the world. This little image here is taken from the Turing Way, and the link is included in here. I encourage everyone to look at the Turing Way. They have fantastic materials that they put together on reproducibility. But here they talk about benefits to the researcher themselves, and among some of the things that they list, they're talking about being able to trace back your own project and be able to see exactly what you did, and then being able to share that more widely. So having a complete track record of the work, which can help with ensuring more sustainability and continuity of the research. It can help facilitate collaborations and review, so allowing other people to have an in-depth understanding of the work and build on the work, so they can test the code and they can make useful changes and build on the science and make it better. Publishing validated research to avoid misinformation. That's always something that we keep in mind. We don't assume anything like that ever happening, but by opening everything up, we as a community are able to capture anything like that if that were to happen. Getting credits, I just want to point that out too. So researchers who publish their work openly with underlying information can get cited more, and also the specific material. There's a movement now to make software a first-class research object. We already think of data as a first-class research object. All of these materials can be cited as well, independently of the publication that they ultimately support. So I just want to make sure that to emphasize that that researchers can do this. When they do this right, it benefits them and it benefits other researchers. That preparing materials in this way can be done with not too much effort, and that it's a benefit to all overall. I do want to mention one caveat here about opening up data. Obviously, this has to be done within the legal, ethical, and other constraints that our community is accepting and lives under, and that especially when dealing with human subjects in my field, and obviously with clinical data in other fields. So for the next slide, please, I want to focus on what we do at ISPS, the Institution for Social and Policy Studies. We, as I said, wanted to open up data and code that underlie the publications that are produced and generated through our institution here at Yale. And so what we thought we would do is basically, before putting everything out there for the world, that we would have a group of us who would act as curators or first reusers of the materials. So we've implemented processes, policies, infrastructure to assess the computational reproducibility of these materials. We build on gold standards that have been used in social science data archives for many, many years, and then added a component of code review, which I'll explain a little bit more in a minute. So basically we did that because we wanted to make sure that if we're putting out the data and the code, and we're saying that this is underlying a particular journal article, let's say, that if someone were to use these materials, they will be able for themselves to see that, oh yes, indeed, this reproduces the results that were reported in the manuscript. So you see here an example of what I think it's a Stata output in this case produces, and how that shows up in the paper. And we do this sort of assessment to make sure that that these things are reproduced. And so what we find in general is that researchers who go through our process do come back. They do better. They give us better materials, more documented, more careful, less unintended errors. And they appreciate that we can help identify and correct some of these unintended mistakes. So the next slide, please. Some of the times it's hard to be able to reproduce results because we don't understand materials on their own, and the author isn't always there available to answer our questions. Sometimes they just don't answer, sometimes they are busy, sometimes they're no longer with us. And so the goal is to try to have a process that can enhance the files, the documentation, the data, and the code to the point where we can package it all together and say, this is the package that really can be used over time, can be archived according to the gold standard practices, and then used by other people. And so building on that, we find that code review is one of the issues that has been most problematic. And that's the issue that I wanted to focus on today. So in this, if we can go to the next slide, in this example here, we produce an author report after we go through all of these steps, talking about, as I said, the data documentation, the files themselves as digital objects, as well as the code. And we will indicate to our authors where any kind of problems arise. It's a small font in here, but when you get the slides later, if you wanted to look, you'll see that the kinds of issues that we come across are not large. They're not threatening the results in any way, but they do, we will flag situations when the code won't run, when there are errors in the code, and we will flag situations when there might be a discrepancy between what the code produces and what is reported in a manuscript, whether it's been published yet or not. I will also make a point here to mention that ideally, we would like to get these materials before the final publication in a journal, right? So we tell our authors during the R&R phase, they already know generally the article is accepted, but there's an opportunity still to correct a few things. Give us the materials. If possible, do it even earlier, before you even submit. But any point before publication would be good, because then we can correct problems that sometimes have nothing to do with the research, but may reflect poorly on the research if it's not reproducible later. So next slide, please. This is how you can explore this later if you wish on your own time, but this is, we expose the materials, we serve it up via our website, and that is the ISPS Data Archive. And I guess my last slide, if we can go to that, is just to give you some helpful guidelines that we have used over the years. The second entry is actually our own. We developed a guide on what to deposit. What does it mean when you deposit data? What do you have to think about? What when you deposit code, what to think about? The Cure Fair Working Group produced the first entry there. That's the 10 things for curating reproducible and fair research. Again, it's for people who are mostly focused on publishing and archiving these materials, but it's a good preview for researchers what to look forward to in terms of what they will need to do or think about if they want to work reproducibly. The American Economics Association, the Turing Guide I mentioned, and their resources as well in the Cure Consortium website. So I'll end here to make sure everyone has time, and I look forward to your questions. Thank you.
Thank you so much, Dr. Peer. Very, very much appreciated. So you've heard some excellent ways of thinking about how to begin curating your materials and preparing these materials associated with your publication. And you've also heard some high-level benefits to both yourself and your field more generally that sharing your data and materials associated with your publication can provide you, as well as reproducible practices and fair best practices more broadly. We now invite Dr. Frank Rockhold to provide some of his great insights into the benefit of and importance of reproducibility to clinical trials and clinical research, some of the history and current state, and most importantly, why this is so crucial to the patients and research participants that are involved in this clinical research and how to best support them. And so at this point, I'll pass over to Dr. Frank Rockhold to present his excellent work.
Thank you, Anthony. Move to the next slide. So I'm going to try and present some of my experience in data sharing, and I'm going to focus on clinical trials. A number of the principles, of course, apply to healthcare data as well, but this talk is going to focus in on clinical trials. I should also point out that I'm involved in various aspects of the HEAL initiative through the Trial Innovation Network and some of our work in pediatric pain. Next slide. So just to support, sort of set the scene in terms of terminology, people use terms sometimes interchangeably. So transparency and the ability to be open or openness are strategies. That's a belief system that you have that you believe needs to be in place. Disclosure and access are necessary tactical actions. The difference between access and sharing, people use that word. Sharing is an active decision to put your data somewhere where somebody can look at it or get to it. Access is simply allowing access. Whether or not the data are actually in place is obviously up to the platform you're on. But the important point is disclosure. Access without transparency might make it look like you're trying to be transparent, but it doesn't help the patients or researchers. And I'm going to get into some of why that's important. And transparency can really only be achieved if people disclose their information in a manner that's digestible by the recipient, otherwise known as data utility. Next slide. So some of these were mentioned by Anthony. And so I'm going to talk about open science and clinical trial data access. Some of the challenges are patient privacy. And there are certainly methods to get around that. I'm going to talk about that a little bit more in a second. In clinical trials is certainly different than it is in public health or sorry, in healthcare data. The challenge of retaining academic credit and commercial sensitivity, people want to retain control of their data. They want to make sure that nobody else is going to do something wrong or do something that they want to get credit for. And there's this sort of, as Anthony mentioned, sphere of the rogue analysis. And that's often quoted as I don't want to give my data because nobody else knows how to analyze my data as well as I do. But I would point out that there have been many, many, many examples of people doing rogue analyses from published data, meta-analyses from publications, data on registries like clinicaltrials.gov. So if people want to do something nefarious, they have other mechanisms to do it. And there's no reason why access to individual patient data from trials is going to exacerbate that. In fact, it's quite complicated to do these analyses. Data standards interoperabilities are mentioned by both of the speakers, and that's, I'm not going to go into great detail there, but hopefully obvious to the audience that in order to make data available to people, practicing good data stewardship is important, and part of that is data standards and interoperability. Resources and money and people in order to create good data stewardship and to be able to access data, you have to have people with the right skills, informatics skills, statistical skills, and those aren't necessarily in ready supply. So that's certainly an issue, and somebody has to provide the money to pay for them. So that that's something that shouldn't be forgotten. But in terms of the academic credit, commercial sensitivity, there really should be room here for the primary, secondary researchers and patients alike to gain from this effort. Next. So there are certainly some challenges, but I think we're at the point in clinical trials now where it's not whether data should be shared, but rather how and when in order to deal with some of the issues. And certainly enhancing reproducibility clinical research that is important. I don't think it's the primary goal of sharing, but it is certainly an important consideration, as Anthony outlined some of those. Most importantly is to honor the contributions of clinical trial participants. When they enter a trial, they sign an informed consent. And that informed consent will say in so many words is, you may not retain or obtain any benefit from this trial or the treatments in these trials. However, the data that we are collecting and you are helping us to collect will benefit other patients in the future. And if we don't actually share the data, the likelihood of it benefiting other patients is going to be minimized. You can certainly use it to improve the design of future trials. And I think that's part of what Anthony was saying. You don't really know the value of your data unless somebody finds a way to use it. And in many cases, generate new research findings through meta-analyses and other mechanisms. So the journey of sharing individual patient data is certainly an evolution. I mean, I've been working on this for 30 years. It's not a sudden awakening, but it is challenging. Next. And just to give a sense of the sort of the recent journey, the last 15, 20 years, you may all remember in 2005, there was a regulation put in place by Congress, and it was also started by the journal editor saying, well, you need to, if you want to publish a paper in our journal, or in the case of the FDA, if you want to file a new drug application, if you have to have registered your trial in clinicaltrials.gov or the WHO, and if for international trials. That at the time was very controversial. The pharmaceutical industry and others opposed it, saying it was going to violate their ability to keep their research under wraps. But nobody questions it anymore. That is standard practice. Everybody understands it. They actually see the advantages and how that contributes to transparency. Well, of course, we moved a long way, and I'm not going to go through each one of these lines. There's a lot of acronyms on here that I'm sure many of you are familiar with. The point is, it has developed over time, in particular in the US and in Europe, to come up with different ways to promote the idea of data sharing. And it's had its sort of bumps in the road. A key turning point was in 2017 when the ICMG put out their requirements for data sharing, individual patient data sharing, and the US Office simultaneously, US Office of Human Research Protection, changed the rules and sort of an informed consent after 2017 in the United States. If it doesn't mention data sharing, the implication is it's okay to share. it had been ambiguous prior to that time. So you can see all the different attempts that have taken place to try and promote the idea of data sharing. And this is really only a sample. There are dozens more. Next. And it was this was a pivotal survey by some folks at Stanford to look at several thousand patients and their attitudes toward clinical trials and their sharing of data and risks and benefits. And of course, one of the challenges is around patient privacy. And what came through clearly in this publication is 88% of patients said, I recognize there's some risk to privacy, but I'm willing to put up with that risk in order to have other people benefit from the data that I risk my life to generate. And there's other attributes in there that clearly show clinical trial patients are overwhelmingly in favor of having their data shared, even though there's certain risks involved. Next. Data utility, there's many definitions of data utility. This is just one from the Organization for Economic Cooperation and Development, who generate lots of data and disperse lots of data. The main part is, in practice, disclosure and control decisions are a trade-off between utility and disclosure risk. And for clinical trials, what that means is you can never make the risk of patient like re-identification zero. There's always going to be some risk. If you make it zero, then you're going to make the data utility very low. So I think that's an important point. It's what I referred to in the first slide. Next. There's a spectrum of data. So the good news is lots of people have figured out ways to share data, and there's dozens and dozens of platforms around where clinical trial data sit. They have different spectrum of openness, I'll say. The ones on the left, Project Datasphere is a good example. That's actually quite easy to access the data. You can download it. You don't have to have a scientific hypothesis approved. All the way to the right-hand side, where there's a very strict review of proposals, and then you have to do the analysis in a closed environment. All of them allow access to individual patient data, just doing it in a different way of accessibility, and all of them have different processes. Next. So one of the challenges, as you've heard, is that people that I mentioned before is that researchers sometimes resist giving their data away. In industrial settings, people are concerned about intellectual property or commercial sensitivity. In the academic world, people are worried about the ability to get more publications or grants. And I think there has to be a coming together of that. And I think there was two great publications in 2016-17, as noted below, where all these authors pointed out that there should be a way for primary researchers, clinical trialists, to be given incentives to share data. In other words, they get a pro-feed acknowledgement of their research, and I'll give you an example of that in a moment. And secondary researchers should have to provide some sort of research question and reason why they want to access the data. Doesn't have to be a zero-sum game. And in fact, the optimum would be if secondary and primary researchers actually collaborate on the secondary question. So the primary researchers gain from getting other people's ideas and efforts, and the secondary researchers guarantee from the knowledge of the primary researchers gain. Next slide. We've been working on this for a long time at Duke, and none of these are earth-shattering principles. You'll see these in a lot of places, I think, that evolve around open science, improves research integrity, promotes transparency, maintains data utility. The one I've highlighted at the bottom, I think, was the biggest shift we had about 6-7 years ago, was getting academic credit to those who share their data. So now in most data set platforms, there's a DOI that's attached to a data set, and if anybody uses it, as a secondary effort, that's actually, you get credit for. It's sort of like a citation in many ways, and you can actually use that toward your tenure, promotion, appointment data that you present to the committee. And so that's been in place. Not a requirement, but it certainly is considered an important contribution to science. Next. So we have a platform at Duke. It's got several components to it. We display data from Bristol Myers Squibb. All of their clinical trial data sets sit on our platform. But we also have 45 years of Duke catheterization data, both in research and education. And we have a long number of other data sets and also from our data set catalog that we run. And this is a system that's publicly available. Next. It's not the perfect system, and it's probably one of the more restrictive ones in some ways. But one of the things we've learned is it takes a village. It's complex to run one of these platforms. You have to have lots of different expertise, a lot of informatics expertise, subject matter expertise, and it's a collaboration, not a competition. So when people ask for requirements around getting to data, we do encourage them to submit a scientific review. But we do review it and we actually try and help them. We actually have only, in the 7 years I've been doing this, we've only actually rejected one proposal. That's because it had already been published. So we do try and work with the researchers by providing subject matter expertise. When there's a proposal comes in, we find a clinician who's an expert in that particular area to help reframe the question. We require data dictionaries, contextual documentation. But one thing I will emphasize on all these platforms, it's not build it and they will come. As a combination of the complexity, and I'm guessing we don't market them appropriately, it's not always clear that the platforms are even available or what it takes to get that done. I think that's an area where we need to improve. Next. So one of just in closing, one of the things that I think needs to change is that there are data contributors, primary researchers out there, and there's data requesters. The problem is those are very rarely the same people. And so it's very hard for one group to understand the needs of the other because they don't walk in that person's life. And so I think the next slide, what we need to get to is where there's a bigger overlap between the contributors and the requesters. And then I think it become clearer to the contributors why they need to have their data be interoperable, why it needs to have a data dictionary, why it needs to have clear metadata. And the data requesters need to understand how complex it is to actually create those things and be more specific in their questions and have some discipline in the way they make their requests. Next slide. So what we've tried to do is in this picture basically say this is there's the benefits certainly outweigh the barriers, and I think Anthony referred to the same thing, but that doesn't mean there are no barriers, and the benefits are important. And you'll notice data integrity is on both sides. Performing better data stewardship, having better data integrity is a good thing for everybody. It's a good thing for the society. It honors the patient contributions, but it also takes work. So in a sense, it's also a barrier. So I think, but if you add up the benefits, in my opinion, they exceed the barriers, but the barriers are there and we can't ignore them. Next. So key summary points: we owe it to patients to enroll in trials to make their data available. They risk their lives to generate these data, and they do it under the condition that other people will benefit. And that alone is a good reason to share. Each view this data access is a journey. It's been changing now for 15, 20 years. And it'll continue to change, and some of that's influenced by journals and legislators. We need to understand what openness and transparency really mean. We need to understand patient privacy as it relates to informed consent and not use that as a complete blockage or barrier to getting something done. The ability to download data is important. I reference this in terms of Project DataSphere. This is one of the biggest issues in terms of people being able to combine data from different platforms or different trials, because they have to operate within a platform. If they had the ability to download the data, then they could get the metadata themselves and it would make it much easier for them to combine it. Data utility is an important concept people need to understand. There's no perfect privacy nor a perfect data dictionary, but we have to understand how to balance those two. Standards and interoperability, obviously important, and creating incentives for both the primary and secondary researcher. So if in the end, if we promote better data stewardship up front, I think this will benefit everybody. It'll make us have data as a better asset, and I think it'll honor the patients who originally contributed the data. Thank you.
Thank you so much to Dr. Frank Rockhold and Dr. Limor Pierre. I wanted to take a brief moment before we jump into Q&A just to summarize a lot of what you've heard today. There's been a lot that's been thrown at you, so I just wanted to do some quick takeaways. Effective data sharing maximizes the analytic value of your data, honors our contribution to research participants, and promotes good science. Following a few best practices for data management facilitates timely data sharing without substantial additional effort. These can be easily implemented upstream, and we have a number of resources to support you. Many resources are available to help, including those provided by us at the HEAL data ecosystem, the excellent work of the Stewards and the platform team, and there's a lot of community work around these issues, and we encourage you all to explore them further. I'll pass it off to Sarah now to introduce everyone participating in the Q&A, and I look forward to all of your thoughts.
Yeah, thank you so much for the presentations, Anthony, Limor, and Frank. We are going to now invite our additional panelists, Phil Schum of the HEAL platform team and Brandy Martin of the HEAL Stewards. If everyone will turn on their cameras, we will now stop screen sharing and begin the panel discussion. The first question that came in, I think we'll start with Dr. Pierre and Dr. Rockhold, but I then want to, if there's any other thoughts from any of the other panelists, please feel free to jump in. The question is, if a publication is made based on preliminary findings, should the full data set, whenever it is completed, be shared in addition to the preliminary data, or do you generally replace it?
When you say, I'm not sure what the questioner say, preliminary findings. So are you saying if the publication may only have, say, the primary and secondary endpoint and there are other variables being collected? In that case, I'd say you should share the whole data set. There are certainly disagreements on that, and there are different schools of thought. The journals only require, for the most part, that you display or disclose the data that you use to generate the publication. My personal view is that you should put the entire data set out there. If the question was if you only have preliminary data, I guess I'm not clear why you're publishing it, unless it's an interim analysis or something. So I guess that's a bit of a special case, but I suppose the general answer is yes, you should replace it with the final data, but perhaps you need to do both.
I'll just add that I agree with Dr. Rockhold. I'll just mention that the question points to the fact that data could be dynamic. Data changes and updates over time. And so I would kind of emphasize the importance of versioning and using tools that can help with versioning, and also documenting a specific version that you used in a specific analysis, because as these things get updated, you could run into a problem trying to reproduce results with a data set that now includes 2,000 more observations, for example.
Yes. Agree completely.
Phil, did you have some comments to add to that?
Only to say that I agree with both of those, and that the HEAL platform has a number of features on it to facilitate exactly that kind of versioning that Limor talked about.
Okay. All right. Question number 2 is, a clinical trial may collect data on multiple outcomes and risk factors, with only a handful of these being included in the primary analysis or first publication. In HEAL, the requirement is to share the data at the time of primary manuscript. So what is the right balance here for timing for the release of data sets not used in the primary analysis? I don't know. Anthony or Brandy, do you want to try that question?
I'm happy to jump in here. I think this aligns with many of the answers in the previous question as well. By all means, share the results and the data that are directly associated with that primary analysis, and make certain that all of those are clearly related to the results that are reported in that primary publication. But at the end of your project period, the platform provides the capacity to link in multiple different data sets and make certain that all of those important pieces of versioning as you release data in waves are noted in those data releases. So we're aware of some teams and studies that will be releasing data in waves. So we've thought about this it's at the beginning of working through the development of the HEAL data ecosystem, and implemented many of those sorts of versionings and release of preliminary and primary and all of the final data at the end of the project period. Brandy?
No, 100%. Yeah, I think that question is very similar to the first one, and so the HEAL platform definitely has tools to help you with that.
I also, if you don't mind, Anthony, I'd just add to that it was part of my answer to the first question. I also think that most of the guidelines that are out there, and including the Institute of Medicine guideline, was originally published in 2015 and been somewhat modified. That the primary researchers are going to have some period of time, a year, that usually there is some sort of embargo period where they can keep doing their work, make sure the paper gets published. And it also depends on when the clock starts, if it's the date of the publication versus the date of the end of the study. And in that time, they are already working on secondary manuscripts. So putting out the full data set after that period of a year or 18 months or whatever it is shouldn't be a tremendous burden to them. I also think there's very few examples of people actually reanalyzing the data that are actually published. It's a lot of hard work, and 99% of the time you're going to get exactly the same answer and you can't publish it. So you've spent a lot of time so it's not necessarily geared at being able to, you're not checking the original researcher, you're trying to use it to do something else, a meta-analysis or fit a model, or so I think you almost dictates that you need the whole data set out there at some point.
Thank you. The third question that came in seems to be more of a statement. So I'll kind of read the statement, and then if you have thoughts on it or the concepts involved, feel free to answer it. It would be ideal to maximize the amount of data shared, but it almost seems disjointed to try to meet the conditions of reproducibility that is described as being focused on the exact derivation and methods used in the primary analysis, at the same time of opening up opportunities for the broad use of all data collected.
Yeah, maybe I can jump in, and it certainly I appreciate that this is a very important statement and question. I think what we'd like to keep in mind here is that, especially when many people are using the same data set or harmonizing and comparing data sets. One piece to keep in mind is there could be a lot of mapping or data munging, or a lot of kind of secondary data curation that could be of importance for producing the results in a single publication or a single analysis. So we want to make certain that all of those assumptions and all of those pieces of the analysis and how that data is altered to create those results or within that particular workflow are represented within the reporting of a reproducible publication and reporting of the reproducible analysis materials, but also sharing that final full all data is also something that we want to encourage. So it is a balance here of making certain that as that data might be munged or cleaned or curated in a particular way for a particular smaller set of analyses, you're making certain that all of those assumptions are met, but also making accessible all of the data with all its appropriate documentation.
I guess if I'd like to just add that it is important, if you look across all in clinical trials, if you look across all the platforms, the vast majority of data sets are never accessed. So a lot of people have shared a lot of data that are not being utilized, and that could be for various reasons. And so I think that's why I made the point about the difference between sharing and access. As long as the people have the ability to get to the data, there may be a delay because people have to publish to put the protocols or data dictionaries out on the site. But I think there is a balance that needs to be struck in a trial of 15,000 patients in a trial. Is anybody ever really going to be interested in every laboratory test that was ever run on all those patients? which could run into the tens of thousands of fields.
Mm.
They're probably interested in a certain portion of the variables. And so being able to get access to it is important. Whether or not they're all shared in the first instance is a logistics issue, and the sort of the likelihood of, I mean, if there were a trial, you know, new drugs for Alzheimer's, yeah, lots of people are going to want to access those data. But there's going to be, I think, certain trials that maybe you do only from a practical point of view. You initially share the data as long as you promise to give access to it all, as long as if it's needed.
May I make just one other final point? I think important that the raw data or the complete data is shared to the extent possible, or there's access to the extent possible. And any derivations that underlie specific analysis are captured in script in some way, scripted, captured computationally. That's what we talk about, computational reproducibility, because then we can understand what happened and we can repeat those steps, but it doesn't take away from having that access to the full benefit and the full use of data.
I agree 1,000%. I mean, in CDISC words is SDTM and Adam, in other words, the derived and raw data and how what the code for the derivation was. I agree, essential.
Thank you. I know we are at time, but we do have one final question and we do have some wrap up end pieces. So I think we are going to continue past 2, but if we understand that with obligations and schedules, if you need to step off, that is fine. This presentation and all of our webinars are recorded, so you will be able to view any pieces of the presentation that are not finished. So our last question is, what specific challenges do HEAL funded researchers face when it comes to sharing diverse data types and ensuring the interoperability of metadata and ontology standards?
Yeah, I can go ahead and jump in here just real fast. I think as more and more investigators begin sharing their data, we're recognizing there's a wide breadth of all those diverse data types across HEAL. So we're trying to find sort of linchpins or common areas where people can begin thinking about mapping to a common data model or leveraging common ontologies and standards. So for instance, if many people are leveraging EHR data, can they map to something like OMOP or other similar standards? If they're leveraging imaging data, can they share open metadata and make certain that they're sharing as much of a reproducible analysis of that imaging data as possible, to even single cell RNA-seq, making certain that they're making as much information, as much context around that data open as possible, so that people can really do clear one-to-one comparisons across multiple different sites or multiple different teams. So there's a lot of diverse data types and a lot of diverse ontologies and standards here. We've been working with our excellent collective board that are extreme experts in their own right, surrounding their own curation in their own studies and their own data types, and beginning to get feedback from them, and also exploring how to best support kind of barrier to entry here to support investigators and leveraging common models and common data models like OMOP and FHIR, and also similar to producing some resources for mapping to common ontologies and standards. One important piece that I'd urge you all to think about is some of your data dictionaries and your variable level metadata. That the Stewards and platform team have done a lot of excellent thought here about how to best leverage that information to support downstream harmonization. And Phil, I see your hand, so I look forward to your thoughts here. Phil, you're muted.
Apologies. Thank you. I would just add one thing, which is, Anthony spoke, there are challenges here, but I'm going to throw out a challenge that we can actually do something about, and it's the following thing. I know a lot of people, we've talked to a lot of investigators who are really keen to adhere to the NIH policy and share their data, but they don't know where to begin. The HEAL data ecosystem has put out a lot of information. I understand it may be kind of hard to navigate some of that. Please ask your repository or ask any of members of the HEAL data ecosystem. We can absolutely help you with that challenge of where to begin, what to prioritize, that sort of thing. Please take us up on it.
That's a great point. I think we've struggled with that here at Duke as well, and I think where we've arrived at as a first step, it's not the end, but it's a first step, is teaching people, anybody doing an experiment anywhere in the School of Medicine, learn to write a data management plan, independent of whether you're ever going to share the data. Because when it comes to the point of having to share it, you've probably done 60 to 65% of the work. You don't have to retrofit, make up a data dictionary after the study's over. And so I think that's because we've had the same issue. It seems like there's a lot to do. And so we're trying to take one step at a time and then give people guidance on, okay, how do I get it onto Vivly, or how do I get it onto the HEAL platform, or whatever. But we're really working hard to try and teach people better data stewardship as a first step, because then it's a lot easier at the end. So.
Thank you very much. And I would like to thank all of our presenters today, Anthony Juehne, Dr. Limor Peer, Dr. Frank Rockhold, as well as our panelists, Phil Schum and Brandy Martin. We're very grateful for your insights. In addition to our presenters and panelists, we would like to acknowledge the behind the scenes team that is listed here that has worked diligently to bring this webinar to production. Next slide, please. And we would definitely like to thank our audience for your participation in today's webinar, specifically, as well as we are going over the 2 p.m. mark. But we hope that you are leaving with a better understanding of best practices for research reproducibility and data reuse. In addition to the recording of this webinar, we will also email everyone who is registered a list of resources. This slide deck will be shared, a link to our Slack channel, and then there is a Connect with Us form that is also located in this chat. And please reach out to us, the HEAL Stewards, for any questions or support as you embark on your fair journey to maximize the value of HEAL data. We look forward to seeing you at our next webinar on Thursday, September 21st at 1 p.m., which will introduce the HEAL semantic search platform called DUG. Next slide, please. We would like to also remind everyone of the next HEAL Connections sharing session on Thursday, July 27th at 1 p.m. Eastern Time. You will find a bit.ly link to register on this slide, as well as the full event link will be located in the chat. Next slide, please. In addition, this is a reminder for the 2023 Data Asset Inventory. If your HEAL study was awarded between 2019 and 2022, and you did not complete the first Data Asset Inventory, please check your inbox and spam folder for a related email from the HEAL Stewards. This effort will assist us in providing additional resources and support to HEAL investigators. Please complete this inventory by August 1st. And finally, on our last side, you can find a full list of resources available to HEAL investigators and those interested in the HEAL ecosystem. We would like to highlight 2 new resources. One is the HEAL Data to Action team has created a DMP tool template specific to mixed methods research. If applicable, please check this out to help in the creation of your study's data management and sharing plan. And 2, REDCap core CDEs are now available in the NIH CDE shared box folder. You can email the HEAL CDE team to request access. Thank you again, and have a wonderful afternoon, everyone.